pressure looks good.
Doubling up. Roger, roll with Atlantic.
Water towers fly!
Flight downside FT off. FT off.
Yikes. You bet. Okay. We don't need any more of these.
All right, folks. You know the drill. Let us know if you can hear us right now, and let us know if you can see some video of the Antares rocket that should be launching here in... Oh, where's the countdown timer? I was going to act like I knew what time it was supposed to launch. Michael, chop, somebody tell me what time this thing's launching.
We are roughly 34 minutes away from the launch of Antares and the Cygnus NG-15 mission to the International Space Station. Yes.
Okay. Whew. All right. So usually this is my process, right? It's like, hey, let me know that you can hear me. Give me a 5x5 in chat. NASA spaceflight crew doing some live commentary. And then I glance up there and I'm like, and we're only 30 seconds. Countdown thing wasn't up there, so... Anyways, we're here to do some live coverage of an Antares launch today. Antares is up at the Mid-Atlantic Regional Spaceport in Virginia. It's Virginia, right? Yeah. And we've got a couple of the regular hosts here to join you and let you know what's going on. Right above me right here, we've got Thomas Burkhart. Thomas, how you doing today?
I'm doing well. How you doing, Das?
Pretty good. And then above him, now I actually moved it over here. We've got Chris Gebhardt. How's it going, Chris?
I'm doing well. I moved, but hello.
See, I switched to this scene because the other scene blocks the little image tag that says the people's name and Twitter handle and stuff. So I switched over here, and then we switched back, and then we weren't actually... Anyways, let's go back to the rocket. There we go. How's everybody doing today? So
doing well.
Oh, apparently we've got some, the name of the Cygnus spacecraft there up on the screen. What's going on? Like, what's launching today? It's an Antares. We don't hear that name a lot. Where is it going? What's it doing? What's our plan here today?
Yeah, so this is an Antares rocket, Antares 230 Plus specifically from Northrop Grumman, and it is launching the Cygnus NG-15 resupply mission to the International Space Station. And like all of the previous Cygnus flights, Northrop Grumman names each Cygnus after someone who is instrumental in the field of space exploration. Mostly they have focused on astronauts, but not always, and this mission is named in honor of Katherine Johnson, who was instrumental in those initial human space flights from the United States, performing trajectory analyses for both Alan Shepard's suborbital Freedom 7 mission and her most well-known work, the trajectory analysis for John Glenn's Friendship 7 mission, the first orbital U.S. human spaceflight, which coincidentally occurred 59 years ago today from Cape Canaveral in Florida. Johnson is one of the so-called hidden figures within NASA, one of the Black women who did not get recognition for her work at the time that it was performed, but has since risen to prominence both in the book and the movie Hidden Figures. And she passed away last year on the 24th of February 2020 at the age of 101. A remarkable woman, a remarkable career, and someone whose hand calculations still help us to this very day in space exploration. So wonderful name for this particular flight. But it is bringing quite a bit of supplies and cargo up to the International Space Station. All told, the 15th overall resupply run of Cygnus to the station. 5-minute launch window here from Wallops, and that will help deliver 3,727 kilograms of supplies and cargo up to the space station. So that is what we are all here and waiting for today.
All right. And I think we've got Thomas there back again. Excellent. So look at this. What is the deal with this shot here? It almost looks like a tiny, like one of those tilt shift rockets for a second. I guess now talking about the expedition up on the ISS and why they need supplies, huh?
I think this was supposed to be like a clean video feed. Shout out NASA for that. But so, yeah, this mission is supporting Expedition 64 up on the space station. But yeah, cargo for the space station, and the previous shot was showing the launch pad, which is in Virginia. This is the Wallops Flight Facility / the Mid-Atlantic Regional Spaceport. What's the difference between the two? Because I think this applies to both, right?
I think-
It does. So yeah, it's a good it's a good comparison because Wallops is the range. So NASA Wallops is the range, just like we would say the 45th Space Wing or the Eastern Range down here in Florida. But the Mid-Atlantic Regional Spaceport is the name of the center, just like Kennedy Space Center or Cape Canaveral Space Force Station.
Gotcha.
Gotcha. And isn't Mid-Atlantic Regional Spaceport, isn't that like a... Is it that? There's Virginia Space, I know, but is it like an organization that supports and coordinates spaceflight activities in Virginia, and they sort of operate the Mid-Atlantic Regional Spaceport on the Wallop Range, so it's like in support of the NASA, but it's also... there's some sort of weird way that all that comes together, right?
There is, yes. Yeah, and you pretty much hit it right on the head. So Virginia Space is the overall organization that tries to attract space companies to come to Virginia. So part of that is the Mid-Atlantic. Yes,
that's how I know. I know Virginia Space because they gave me some mints, and they gave me a pen, and they gave me a pair of socks when I was out there for an Antares mission. So that's why I knew what to say.
I bet on today it's the socks that are coming in really handy because it's Berber chilly everywhere except for Florida. And Berber chilly is an official weather term. Yes.
Berber chilly. So this looks like they're rolling some pictures of rolling out of the hip. Yep. They've got a horizontal integration facility over there, and these would be from days past where they're actually moving the Antares rocket out to the launch pad. So a lot like SpaceX. They integrate horizontally and they roll out to the pad, right, Thomas?
It's interesting because this Antares and Cygnus vehicle both came from the exact same program that Falcon 9 and Dragon came from. These are the two commercial cargo vehicles that are supporting the International Space Station, and so there's a lot of similarities. They both are integrated horizontally. They both come out on sort of these transporter erectors. I don't know if Northrop calls their actual structure something slightly differently, but it's the same purpose. Roll out the vehicle horizontally and then lift it vertical. So that's very similar. They also both have that late load capability where once they roll it up to the pad, they can access the cargo vehicle and add stuff to it. For Cygnus, they actually pop the top of the fairing off and they can access the forward hatch of Cygnus that way. So that's how they load any late cargo, such as if they're bringing up like mice or something and they need to have supplies for them. That kind of thing gets late loaded, or anything that needs like special thermal conditions or stuff like that. But either way, yeah, so there's a lot of actually similarities between the two systems because they're both kind of designed to the same
That's the top
criteria.
Of the fairing right there, isn't it?
Is that what that is? It looks like
it. That's the clean room.
It is indeed.
Yep.
Yeah.
They basically roll out a big old clean room to the top of the fairing. And and then that's what you're looking at the inside of here, so that's very cool. So this would have been done last night.
Real quick, you know like you're at the airport and they have those trucks that sort of drive up next to the plane and they raise the big box up and they load all the snacks on.
It's
they
basically
have that for Antares. Yeah, this shot is like the interior of that. Whoa, hold on there, jeez. Careful there, folks. They have this big service floor. It's like a mobile clean room that rolls up and the entire thing lifts up. The big room lifts up and then they pop it on the top of the rocket. They can take off the top of the fairing, like Thomas was saying. That's literally what they're doing right there. They're putting it back on here, and they can late load stuff. Like we said, you have the mission cargo all ready to go days, weeks in advance, but there may be some things like perishables or live animals that are going up for experiments on the station, and you need to get those into the rocket right before launch.
There you go. You got a picture of the entire setup there.
Oh, nice! You can see the little raising room with a hole in the end of it that connects to the end of the rocket. Nice.
Yeah.
So and of course SpaceX has a similar program. Of course, now with the new Cargo Dragon 2, they actually use the crew access arm to access the side hatch on Dragon and do their late load that way. Because of course it's also a crew vehicle. But same kind of requirements that both Falcon 9 and Dragon and Antares and Cygnus are designed to, because they're both catering to that same program.
Yeah, and since we've got this up, they're going to change it as soon as I say it. But we've got two engines. Not really. We've got one engine with two combustion chambers. How do we rate this engine?
That's two engines, right?
Atlas. Is that technically two engines?
It's two separate engines, right, Chris?
Okay.
The RD-81 is a derivative of the RD-180. I believe it's just one with double.
I think that's the difference. I think the 181 is two separate engines with one combustion chamber each, unlike the RD-180, which is one engine with two combustion chambers.
What's the
I think
difference?
that's the difference. So basically, it's basically the same engine. It doesn't actually make any functional difference, but technically, I believe, and Chris is looking it up.
They have a huge thrust difference in them.
Right.
There is a large difference between them in that regard. Yeah. I am looking it up though because I want.
Because
Well,
it
let's
always
see where that
confuses me. Yeah, on this one the thrust is 2. I like that. I see chat saying the thrust is
There you
2.
go.
Antares, the thrust is only 2. So it's always sort of confused me because there's the 180, the 181. They're derived. One's derived from the other, but they say that one is.
So sorry, I misspoke.
Go.
So the RD181 is derived from the RD191. That's the difference.
Okay.
Oh, okay.
That is the difference. Based on
So
the
there are-
RD191, it's adapted for the Antares rocket. The two RD181s. So yes, 2. The 2
Right.
RD181s. Yeah.
Two
so that's the
RD181s.
difference, yeah.
Okay. It's
So
like
if
a
you
weird.
look at
Yeah, go.
Yeah, if you look at the first stage of an Atlas V, which has the RD180, a similar but not the engine that it's derived from, you'll notice there are 2 nozzles, so it looks like, oh, there's 2 engines. But in reality,
right.
that's actually 1 engine that has 2 combustion chambers. On Antares, they're not playing that trick on you. It really is just 2 engines. And yeah, so those are the 2 liquid fuel engines, also fueled by RP1 kerosene and liquid oxygen, just like the Falcon 9 vehicle, the other CRS vehicle.
Yep.
So another similarity there. But yeah, that's the first stage of Antares.
I wonder if it's just like, okay, you want an RD180, this is how it comes. It has 2 engine bells, 2 combustion chambers, but they're packaged up in 1 unit, right? 1 engine unit. But these, could they take an RD181 and just have 1 of them on a rocket?
They could.
Okay, because it's
I mean,
1 engine.
you wouldn't have
It's
you would
2
have half the
engines.
thrust as normal,
Right.
and I don't know if you get much lift capacity, but it is 1 standalone engine that they just put 2 of in.
Okay, it's just one of those things about the Antares that's a little bit different. It looks like the bottom of an Atlas V, kind of. Got different boat tail and stuff on it.
Yeah.
But anyways, moving right along, it looks like they're continuing to cover some of the science that's on board, and this looks like a high-performance computer. Worms.
And now
They're
we
sending
got a
worms
worm.
to space.
There are worms. Yes. So the worm one is
I
really
think-
cool because it's about muscle loss, and we, even though our astronauts exercise a lot, we still see muscle loss that is very similar to advanced aging here on Earth. So this is an experiment that's looking at gene expression in muscle loss to try to figure out if there is a way to study this phenomenon in that would benefit people here on Earth who suffer from muscle atrophy as they age.
Interesting. It looks like they've got some sort of grid and they're marking where the worm has been and where the worm's going. And it's like, you can tell the green and the red, the worm knows where it is because it knows where it isn't.
Oh, jeez.
Hey, let me grab some super chats really quickly here, y'all. I know they've been building up for a little bit here. Rough Riders, thank you so much for the support. It's saying, how's the current schedule going to hold up with Starliner, Crew 2 coming up, taking up all the ports with Crew 1 still up there. Antares takes a port. With this mission today, it would be docking, berthing, actually, to the station because Canadarm2 grabs the Antares. Well, astronaut uses Canadarm2 to grab the Antares and plug it into the station. It
Well,
berths.
Cygnus.
So-
If it grabbed
sorry.
Antares, that would be
Thank
a little
you.
weird. But
That would be a little weird. Cygnus is the name of the cargo spacecraft on top of Antares. But how is the schedule looking? Like, are they going to run out of docking ports on the station?
Well, so that's an important distinction because Cygnus, like you mentioned, uses Canadarm to berth to the station, which means it uses an entirely different port than the
Right.
vehicles that dock directly to the station. So this will use one of the berthing ports on the Harmony module, correct, Chris?
Mm-hmm. Yes.
Yes, cool. I did read the article this morning.
Oh no. So, yes. Harmony. Yes.
You read the
Yeah.
article this morning.
I did. So, so that does not take any of the 2 ports that are there for docking vehicles. So vehicles such as Dragon 2, both the crew and cargo variant, and Starliner. Those vehicles use the 2 docking ports compared to. Yeah, go ahead, Chris.
Sorry, Thomas. It's Node 1 Unity, not Node 2 Harmony, is where
Okay.
it's going.
Okay.
Unity is where it's going. Yes.
Gotcha. So this will berth to Unity. There are 2 berthing ports, correct, Chris? Total?
Yes. Yes.
So this will take one of the berthing ports. I don't believe either of them are taken right now, or is there a Cygnus up there right now?
There's not a signal.
No, the other-
That's a
it
good
just left.
question.
Right.
Yes,
So
it
the
did.
only
Yes.
U.S. vehicles that are there right now is the Crew 1 Dragon Resilience, right?
Yes, that is
On the
correct.
U.S. side? Cool. So there will be one of the 2 docking ports is taken, and after the Cygnus arrives, there will be one of the berthing ports taken. So they do not interfere with one another, to answer the question.
Correct. And
Gotcha.
the reason Cygnus usually tries to go to Unity, because there are 2. There's one on Harmony and there's one on Unity. And the reason, I'm sorry, I get them confused a lot because it's easy to do sometimes. But Cygnus usually goes to the one on Unity because the Japan HTV vehicle, which is currently transitioning between its 1st generation and 2nd generation right now, usually uses the one on Harmony because of where the robot arms have to reach in and grab the external cargo to get it to various elements onto the station. But technically, it could go to either in this regard.
Gotcha. I'm going to grab a couple more super chats here as we go through. Steve-O saying, greetings from very near Wallops. Glad to be watching live and with y'all with NSF. Thanks for all. Steve-O, you're actually out there watching it live from somewhere near Wallops and listening to us for commentary. Excellent. Antares, Wallops, Mars, whatever you want to call it, is such a fantastic place to watch a launch. So I'm actually a little bummed I'm not out there. I've been to most of the Antares launches, and it's just a great place to watch a launch from. Thomas Enfang says, it's my birthday today. What better way to celebrate than with a rocket launch from my state? Thanks, y'all, for everything you do. You rock. Thomas, I'm not going to sing to you, but happy birthday to you.
Happy birthday.
Happy birthday indeed, although now I want to hear Das sing.
No. Obligatory, let's light this candle for your birthday. Sort of bit, and then we'll move on. Let's see. Thomas Simbridge says, hello team from Plymouth, UK. Love seeing some faces along with the voices. Everything looks stunning by the water for liftoff. Can't wait. I mean, look at the shot right now. It's like right there at the beach. You go over those breaker rocks, and every single time you go out there as media, somebody gets in trouble because you're not supposed to go climb on the rocks to get a really cool picture of the rocket. And every single time, the people at the press people are like, get off the rocks, like yelling at somebody who hasn't been there before and is rooting around in the rocks trying to get a good shot. But you're absolutely right. It looks fantastic out there today at Wallops. Let's hope we get a good launch. JD Brown says, how are science experiments returned to Earth after any resupply mission, and what do they use to do just that? Sounds like a loaded question to me, interestingly. But Chris, how do we return? What spacecraft could return science from the station?
Well, it is funny you ask, because there is an experiment going up on this station, on this mission, that has to come back. And the problem is that Cygnus doesn't bring things back in a recoverable condition. Cygnus is a disposal vehicle, so Cygnus serves an equally important role of all of the trash that's no longer and the experiments that are done but no longer needed because they just transmitted their data to the ground and you don't need anything back. You don't want to use a Dragon vehicle that can bring stuff back successfully for recovery to dispose of your trash. So you use the Cygnus. On the US side, you use the Progress. On the Russian side for that. But specifically, a protein crystal growth experiment on this mission needs to come back to Earth so the crystals can be examined. And in order to do that, they will come back on a SpaceX cargo vehicle or a SpaceX Crew Dragon vehicle, because the Crew Dragons can bring back a small amount of powered powered equipment. So if things need to be kept cold, if they need special things, Dragon can do that in a limited capacity with Crew, or it can do it in a much larger capacity in its cargo-only variant.
Yeah, and I will tell you that Cygnus can do something that you would never do on a Dragon, these fancy reusable things. Cygnus, one of my favorite things that they've done with it is they've set it on fire inside.
Yeah.
Not really. But the Sapphire experiment, they've actually run experiments on Cygnus spacecraft after they leave the station. Sapphire was an experiment used to study the progression of fire, like how fire behaves in space. And you never want to light a fire inside the ISS or inside a Crew Dragon that's supposed to come back home, a cargo Dragon, especially a Crew Dragon. So on the Cygnus and previous missions, they actually had the Sapphire experiment, I think a couple of them actually, and they had a special rig that would go through and light a fire inside the spacecraft, and they would have these video cameras watching how this material would burn so they could study the movement of fire in space, something that you'd never do otherwise. And it was fine because Cygnus was burning up anyway, so they just started the burning up a little bit sooner than scheduled, I guess. So, Thomas, go like this for me real quick and just see if you can keep the cameras.
Oh, yeah, we have that weird visual bug. We don't really
We'll have to
know
look at
how.
that some more.
Yeah.
Sometimes if you just like change the camera a lot, you can convince it that it needs to re-encode, like literally just do that sort of thing with your hand over the screen. But that's okay. You look very
cool. I'm wearing a cool shirt. I don't know. Oh, look, I kind of worked.
All right.
You know what else I really love about Cygnus, though?
Yeah.
Das.
Go.
Is that once it arrives on the space station, it also becomes an additional module. So it's not just a cargo ferry up and back. It has ports that you can plug science experiments into, so they can use Cygnus as an overflow or to perform some of the experiments that it itself brings up.
Gotcha.
But they can also use it as for overflow periods, like when cargo dragons come up and there's a real flurry of activity because a lot of it has to come right back down in 30 days on that same vehicle.
Yep.
Cygnus, if a Cygnus is there, NASA can just say, hey, take that one from this and plug it into Cygnus. And
basically, they throw their empty
plug and play,
Amazon
and there you go.
boxes into Cygnus, like when they're unpacking.
Pretty much, yes.
That's cool. I didn't know that they could actually move experiments and use that usable space. It's not just like drawers that you carry cargo in or whatever.
Yep,
I got
and
a couple.
lot of that stems from exactly what you had just said, though, that Cygnus is used afterward to do experiments. So it can also be used when it's there to do experiments as well.
No, this shows exactly where it will be berthed on the station with relative to all the other spacecraft, like we were just talking about. So there's the visual cue if you prefer that.
Yep. Excellent. Let me get a couple more super chats here. I'm trying to get to a specific super chat. Marcus Miller, thanks for the 10 DKK. Twice in a row there, it looks like. Did that twice. We appreciate the support. Moldy Space Industries in the hashtag Thomas Fan Club. How you doing, Moldy Space, today? And then last but certainly not least, this is from Cheryl Burkhart. Do we know them?
Uh-oh, I might know that person.
Anyways, it says, love you all. You make me smile. I intend to meet you all one day. Dash Nana B. And it's
That'll be my grandmother.
Thomas.
What's up? How you doing?
Yeah, so
there's been
Nana,
like a trend
can I
of
call
my
her
family
Nana B?
invading our streams recently, hasn't there?
Your
can we
family
all...
joining our streams, Thomas.
Yeah, you're right. Always welcome. Always welcome.
Thank you so much. Again, that was $99.99, $100 there from Nana B. Is it Nana or Nana? Nana?
Nana is what I call her, Nana, since I was very little.
Deal.
Yes.
Excellent. Well, thank you so much for not only the support there, but for joining the stream. We're glad we make you smile. We have an awful lot of fun doing this, and we're able to do it because people keep showing up. I mean, Thomas and Chris keep showing up. People in chat watching keep showing up. I could just be here like waving my arms in the air to nobody, but I appreciate y'all all joining us so that we can share stuff like this. Less than 15 minutes now. Chris, do we see any specific venting like with the SpaceX craft, the Falcon 9, or like, okay, T-20, we see this venting.
Right.
Is Antares just not as active? There's a little vent.
So this is actually a great way to point out a big visual difference between what the Falcon 9 does, which is really unique to it, and how other rockets do it. So most rockets, when you load cryogenic oxygen, liquid oxygen in this case, you're just using what we refer to generically as liquid oxygen, whereas SpaceX and the Falcon 9 uses densified liquid oxygen, so they cool it down even more. And that fueling process results in a more efficient way of load it, let it boil off in the tank, and then vent it in two big goes at T-20 and T-2.5 minutes. Whereas the Antares does what most vehicles do. You just kind of open up that vent valve as you start loading, and you just let it boil off naturally and continuously until you need to close the vents for tank pressurization for liftoff. So no big vent from Antares, but that little vent is what we can expect up until the moment we need to pressurize the tanks for flight.
Gotcha. So it just sort of boils off constantly. Sounds like we might get some audio here. We might get some audio here.
And launch team LC countdown 1. At this time, on a poll to proceed with final countdown. GSO.
Aha.
GSO, go.
RSO.
RSOs, go.
TD.
TDs, go.
Prop lead.
Prop leads go.
Stage 1.
LC, stage 1 is go. Helium topping is ongoing.
Copy that. Core 1.
In honor of Alexander Diktarov, the late Director General of the Yuzhnoye Design Office, whose efforts in international spaceflight have contributed to the success of Antares, Core 1 is go.
Copy Core 1. MES 1.
MES is go.
GC.
GC is go.
And ACE.
ACE is go.
Mars.
Mars is go.
CMD.
CMD is go.
LD.
LD is go.
NG.
Northrop Grumman is proud to honor NASA mathematician and space visionary Katherine Johnson, whose computational brilliance and relentless pursuit of excellence set the standard for 60 years of NASA mission success. Katherine humbly yet forcefully broke through barriers of gender and race to enable the future of human space exploration, and in the process inspired generations. On this anniversary of John Glenn's historic Friendship 7 flight, which would not have been possible without Katherine's calculations, Northrop Grumman and the SS Katherine Johnson are go for launch.
Copy, NG. Launch team is go to proceed with final countdown. Check 393.
All right, so we just heard the go no go poll there.
Of interesting note, because it is something for what they just said, that with the Friendship 7 mission of John Glenn 59 years ago, today not being possible without Katherine Johnson, it is worth mentioning that John Glenn refused to fly that mission until she checked the computer's calculations of the flight trajectory and said, once she says it's good, I'll get in it.
Is that a real thing, Chris? Like, that wasn't just for the movie, like this dramatic thing for the movie?
Nope,
That's
that was real. That actually happened.
That was real.
Really?
Yep.
I mean, you watch a movie like that and you expect, oh, they're going to embellish some things and stuff, but that was for real, where, the scene was
real.
He's on the phone, like, have her check it, and they're like, she says it's good, but he did actually ask. Maybe not the phone
movie
like that.
magic, you condense it, but no, the actual statement, the actual thing really did occur. He really would not refused to get in it until she checked.
No kidding.
Yep.
That's cool. I appreciate they put stuff like that in, and it's sad that I've been trained by movies to like, oh wow, they probably made that
just
part
assume
up
that was not actually how it happened, right? Yeah.
Yeah, but that's cool to hear that that's actually what happened. I think all the cameras that Wallops uses, they're actually like remote-controlled robotic cameras like we have, and you can see the wind looks like it's going.
Yeah, it is a little windy down there. Of course, in constraints, as they just pulled go for launch, but I do know there was a little bit of surface winds down there, so the cameras might have a little sway in them. This camera feed looks good.
Yeah. It is worth noting, Antares has an incredibly high wind limit of 29 knots, which is 33 miles an hour or 53 kilometers an hour. Impressively high for a low thrust to weight rocket that kind of lifts itself gently off the launch pad. But yeah.
It also slides a little bit, right, Chris? We should talk about that.
It does, yeah. So at liftoff, it will do this really cool thing that depending on the camera angle, if they're on the right camera angle, it will be very, very obvious, and it's called the bomb guard maneuver. So basically, right at liftoff, when the systems release the rocket and the transporter erector, basically to clear the transporter erector and try to get away from it so that plume impingement doesn't destroy it or do it a lot of harm, they angle the engines almost immediately after liftoff so that the rocket kind of drifts sideways as it heads off the pad and angles away from its own pad systems. So that is something to look for as well. And it's named after someone. It's named after Brian. No, it's named after someone named Bob Gardner, who came up with the idea of doing that for these particular missions. So that is something to look for at liftoff as well.
The other really cool thing about Antares is the second stage. Second stage,
which we definitely have to talk about.
We have to talk about the second stage real quick.
So Antares,
whenever you want to, because we deep dived with Kurt Eberly about this.
Let me overview it really quick, and I know Chris can deep dive. So first stage, pretty standard. 2 liquid fueled engines, RP1 kerosene and liquid oxygen. It does do a little bit of power slide off the pad, but otherwise a pretty standard liftoff. They don't even throttle down for max Q anymore because they recently upgraded some of the structures and loads on the vehicle where they don't even have to throttle down for max Q. So full thrust the entire way. In that sense, I guess it might as well be a solid motor. But anyway, liquid fueled first
well, even
stage.
they throttle down.
Right, yeah, on the way up. And then when the first stage runs out of fuel, it shuts down. And I believe separates right away. Like, there's not a delay for stage sep, right?
It's very, very close. Yeah, it's shut down and sep very quickly.
Right.
Yes.
And then the payload fairings separate, but not after the stage 2 ignites, because the stage 2 is solid fueled. So it actually, the second stage and the Cygnus spacecraft coast for a little bit, get a little bit closer to apogee, and then the second stage is ignited and it's a solid motor. So once you light it, it's just going to burn till it's empty. And that's how they conduct a precise orbital insertion that has to rendezvous with a space station. This isn't like, oh, just get it to a low Earth orbit and you're fine. You got to rendezvous with something. But they're doing that with a solid fueled upper stage, which can't be shut down once you light it. You can't burn until you reach a certain velocity target and then shut it down with some fuel reserves in case you have like an underperformance or something. So Chris, How in the world does that happen?
Yeah. So if you've ever tried Kerbal Space, you know how hard this is to do with a solid propellant upper stage. So the basic way they do it, and goes back to the 1970s when the space shuttle was being designed, and the shuttle was a beast in its own right of how to get it to orbit, because you couldn't actually get it out of the atmosphere during ascent, which is completely counterintuitive to how you want to normally launch a rocket. So they had to create this whole new software system to account for that, and it was called Power Explicit Guidance, and it has become the industry standard for what's used. So basically, for first stage of flight for Antares, it's just following a pre-programmed script. If it is this many seconds into the mission, I'm pitched this direction, and this much. If it's this much, pitch this. But when you get to stage shutdown and separation, the onboard guidance systems that have been monitoring everything click over into problem-solving mode, and they have to arrive at a solution of how to fly this vehicle on a solid propellant upper stage so that the stage burns out right when you hit your orbit insertion targets. So the way it does it is it looks at how the bottom, it does this all within like 20 or 30 seconds. It looks at how the first stage performed. Was it nominal? Was there an underperformance? Was there an overperformance? Where am I? What's my velocity? Where do I need to get to? And it calculates not the most efficient way to get to orbit, which is what all other rockets do. It calculates the least efficient way so that I can burn all of the excess propellant and still end up right where I need to be when the final grain of solid propellant is burnt and the motor shuts down. So about 20 to 30 seconds after stage sep, after the payload fairings have separated, you will hear them call out guidance has converged. And that is the indication that the onboard systems have arrived at the solution and they know how to get the vehicle into the proper orbit.
So basically what you're telling me is that it has to use all the fuel. It has to use all the energy in the second stage. So it just sort of gets on its way and it's like, oh, I got extra fuel, do donuts, and then it finishes off the road. It doesn't really, but it's literally just changing its trajectory to burn off the extra fuel, right?
That's exactly what it's doing. Yeah. And because inclination is so important, Das, exactly what you just showed, the pitch up, pitch down, is how it does it. It doesn't scrub it side to side. It scrubs it up and down because you have to hit the exact inclination.
So it's literally it's literally nosing up a little bit, nosing down a little bit to change. Like anytime you're not going straight forward, you're losing a little bit of your energy. Is it a cosine loss in this case, Thomas? Where you're
cosine
not,
loss. Yep.
It's a cosine loss. So you want to go this way, but instead of putting your engine exactly opposite you point your engine a little bit off, and it lets you steer so you can actually change your trajectory some, but you also lose a little energy in that steering because you're not pushing straight on the load. It'd be like pushing sideways when you want to push a block forwards or something, right? So they're literally just burning off extra energy by wiggling a little bit. I mean, I don't think the engineers would describe it that way, but...
Well, the wonderful way they described it to me, right, is like when you get in your car and you say, okay, like I need to get from here to here, right? And it calculates a couple different routes, right? It calculates shortest distance, but also shortest time.
Yep.
But what Antares is trying to do is go, okay, I kind of want the shortest distance, but I need to avoid the toll roads. So I need to go around the toll roads. Like that's the analogy they used when they were describing this to me.
I want to go around the toll roads. Nice. So we're less than 3 minutes from launch here. We haven't heard anything over the net. We got the good go, no go poll there. The weather looks nice. We know they're watching winds and upper level winds because out there at Wallops they're releasing balloons and looking at winds at different levels and all sorts of stuff. Do we have any final update on weather or anything like that? Or here at T-minus 2 minutes and 38 seconds, are we looking good?
As of at T-minus 5 minutes, they did put out a quick update that said everything was still go. So right now, everything tracking on track is on track for an on-time liftoff. The exact liftoff time is 12:36 and 50 seconds, if you're into that kind of thing. But yeah, so we're coming up on the launch in just over 2 minutes.
And if you're really into that thing, the window is not 5 minutes long; it's 4 minutes 59 seconds long.
Nice. Is that pad audio? Sounds like something venting.
This is the sound of some of the GSC. Yep. And
Mark.
What was that mark for?
T-minus 2 minutes.
And counting.
Okay.
Yeah.
I was just making sure it was something else. Okay, gotcha.
Yeah,
So
and I was
we're
looking
under
at the
2
clocks.
minutes now.
And our clock matches Wallop's clock, so Michael has taken care of that. And it sounds like the audio was like 1.5 seconds off or something. So we should be good to go there.
And it will be
Again, folks-
interesting. Oh, go ahead.
Oh no, I was going to say again, this is an Antares, this is NG-15. It's a Northrop Grumman launching supplies up to the International Space Station. They've got science experiments. 1 minute 30 seconds there. They've got clean clothes for the astronauts and all sorts of new science experiments, a computer on board, some worms apparently, but that's what we're standing by. Thomas, let's see if we can squeak one in. What were you saying?
Yeah, I just wanted to point out that at T-0, you will not see the rocket lift off right away. That is the time when engine start is commanded. The vehicle doesn't lift off for like a couple seconds after that. So when it gets to T plus 1 second and the rocket's still there, don't panic. The engine's you'll see the engine about to light up, and then we'll have a lift off. So that's what we're looking forward to. Just under a minute to go.
And that was the T-1 minute call out right there. So again, that is what we should expect. It's all different rockets do things different ways, and when this gets to 0, that's when they start lighting the engines. They spool up for a couple seconds, make sure everything's cool, and if everything's cool, those explosive bolts, we didn't even talk about the explosive frangible nuts or whatever they are down there that hold the rocket on the pad. But coming up on 30 seconds here from the Mid-Atlantic Regional Spaceport.
T-minus 30 seconds.
So this is when we say, go Antares, go Cygnus.
Yeah.
And Godspeed to the SS Katherine Johnson.
All right, the water deluge system has turned on.
The electron pad there in the foreground too.
Oh yeah, we didn't even mention that.
Here we go. That was T-minus 10 call.
5, 4, 3, 2, 1. We have engine ignition.
Main engine start.
Spool it up.
And
Look at that.
Up in Terry for the NG-15 mission. The long flight facility.
Was that the slide? It looked like it slid a little bit.
Yep, a little bit, and now it's going to start pitching down range.
Nice.
All
So at this
systems
point,
nominal.
so at this
The
point,
SS
it is
Katherine
following a
Johnson takes flight
pre-programmed
on
pattern,
this, the 59th
X number of
anniversary
seconds
John
in. This
Glenn's
is my
Mercury
pitch.
flight carrying 8,000 pounds of cargo to the International Space Station. Good performance on the first stage so far.
We got the official call out there. Chris, you were saying?
All systems nominal.
Yes, and it's basically the same thing. I just went into a little more techie detail and nerdy detail.
Yeah.
So right now those two engines, like we said, are going to remain at full thrust. It will go through a period of maximum dynamic pressure, but it will not actually need to throttle down for that. It can handle the loads at full thrust, and that's what we're going to be coming up on here very shortly.
And that was actually one of the improvements to the over the Antares 230 to the 230 Plus variant, was reinforcing it so it didn't have to throttle down, because if you don't have to throttle
Engines
down, you
remain
can carry
steady.
more payload.
Attitude nominal.
God, look at that pitching over. It just seems like it's so fast all of a sudden. It went from like 45 degrees to almost.
Attitude nominal.
Look at that.
And that was just the call out there through max Q.
First stage passing through the area of maximum dynamic pressure on the rocket.
And that is the point where as the vehicle
90 seconds
ascends,
into
it goes to thinner and thinner air, so the drag is decreasing, but your speed is increasing, which increases your drag. So at
First
some
stage
point,
burns for
your
a little
increasing
over 3
velocity
minutes,
and
3
the
minutes, 18
decreasing air
seconds until
density
main engine
kind of
cutoff.
converge, and you reach a point where you've reached the maximum pressure, and then after that, the pressure starts to go down to the very thin atmosphere.
Yeah, and you can actually see the pressure going down
90
on the
seconds,
camera right
stage one
now.
burnout.
Yes, because you can also see that thrust expanding, which is again a function of air pressure around the rocket. So
Yeah.
Attitude nominal.
Attitude
Engines at
nominal.
100% and steady.
Nice. So look at that. You see how the exhaust plume gets bigger, it gets wider and wider? That's a sign that there's less air pressure up there. As the air
Plus 2
pressure
minutes.
drops, the exhaust plume is able to spread out even more, and you get more and more. It's plume expansion, it's called.
All
You can
subsystems
see.
continue in nominal performance.
I'm trying really hard to stop as soon as I hear them saying something. Everything sounds nominal. But look at how wide that exhaust plume is now. It's just there's less air pressure up there to keep it in that little pencil-thin flame. And the worms are riding into space.
are those? Is that the only live cargo on today? No mice or anything?
No
Worms were the only
moustronauts?
ones they mentioned. As
Yeah, I think that's the only one I saw
this
too.
one.
We'll be ready
No
to ship
moustronauts,
down
if you will.
to 80% on the engines at 170.
And that throttle down is to maintain the G-force accelerations on the
Start up
vehicle.
slow
Right.
throttle down.
Throttling
we
down
are
at 3 minutes
coming
into the
up
flight, main engine
shortly
cutoff
at
coming soon.
stage- yeah.
Yep. So main engine cut off. The two engines, the RD-181s at the bottom, are going to shut down. They're done with their
Throttle
job. They're
down
done
to
with fuel.
55%.
And then we'll see the upper stage. Oh, I don't know if we'll see it, but then the upper stage will separate. They'll light that SRB, and it'll continue its way into orbit.
Main engine cut off.
How long is the coast between
We
stage
have
step
Rico,
and stage 2
and
ignition,
Terry's
Chris?
entering
It's like
into
a couple
coast
minutes,
stage.
right?
About a
Fairing
minute.
Separation will
About
occur
1 minute?
30
Okay.
seconds later.
Yeah.
And there you go. So now they're showing
Switching
the
to
telemetry readouts, which the sort of
Some
a
controlled
visualization
firings,
of what the
on
spacecraft looks like as
interstage
well.
of the rocket.
Attitude nominal. Good separation.
Really quickly, when you see the little blue
And-
cones, those
20
are
seconds
thrusters
to
firing
Stage 2 ignition.
Yep.
to maintain. They have little side thrusters to maintain the roll and pitch and stuff like that. So they're actually illustrating
All
that.
subsystems nominal.
Now you see fairing separation, and
Fairing
we'll be looking for
separation.
stage 2 ignition.
And we got
They separate the
confirmation
skirt?
that the
Interstage
guidance had
separation.
converged.
Confirmed fairing separation and interstage.
And there
There
is
we
stage
go.
2 ignition.
Stage 2
So now what I
ignition.
want you to look at on the right hand
Stage
side,
2
you see
ignition
apogee
confirmed. Stage 2
39,
is a solid
right, and you
rocket
see
motor burns for
perigee
about 2
negative
minutes, 44
5,100. It's that perigee that we're trying to raise that from underneath the Earth now, and make that a positive number above 121. We need
Stage 2
above
will continue to
121
burn for
kilometers
another
for a stable orbit.
approximately 2 minutes.
What's the
Yeah, I also
target
wanted to-
perigee? Because it'll be a little higher than that, right?
It'll be a little higher than that. So there is a range that Antares
Altitude,
or that Cygnus can be
138
inserted
kilometers.
into. So it varies from mission to mission, and I did not ask, so I don't want to give it away, but I don't want to say it, but it's going to be somewhere upwards of 180, 190 is what we'll be looking a perigee for.
That's interesting. Look,
because it's a solid motor.
Mission
There's
time,
a
300
box
seconds.
that they can put it into,
Velocity,
not a precise
4.8
like
kilometers per
302
second.
by
Altitude,
190.
150 kilometers. All systems continue to perform nominally.
yeah.
Good
Look
call.
at this.
5
The
minutes 15 seconds into today's flight.
the window open and window close. It's like they have two tracks there on
Right.
the
Mhm.
map, and
Stage
it
2
looks like
motor
one is
pressure,
labeled.
nominal.
So they'll be largely
Exactly.
following that blue line because they launched right at the opening of the window.
Yeah.
But they have a little tiny bit of give based on how Cygnus can maneuver after launch in order to still rendezvous with the station. And you can see,
Yeah.
I mean, you can see on the graph how much of a slight difference it is. But yeah, it'll
It's
be
almost like
largely
the
on that blue line.
corridor.
Yeah,
They
and
need
it's
to
not
go
like
down
you're
that
supposed
track.
to be in the middle of the corridor, and if you're like on the edge, oh, you're near your margins. That's not what it is. It's if you launch at the opening of the window, you want to follow the blue line, so it'll be right on
there.
there.
Burnout.
Right.
And
And
we
y'all,
just
we're-
heard that call out roughly a minute to stage 2 burnout. So watch that number, watch that perigee.
Yeah. And we're trying really hard.
All stage
They're
2
doing
and GNC parameters continue to be nominal.
a lot of call outs. We're trying to listen,
6
but
minutes,
also
15 seconds into the flight, coming up on stage 2 burnout of that solid rocket motor that'll initiate a 2-minute coast
There's
period
also
until,
PAOs
second
talking,
stage
which
separation.
there weren't supposed to be, but oh well.
but also
and here
we're
comes that perigee.
really excited about rocket launches, and there's like 1,000 things we want to explain as they're going on, and it's tough for us
Starting
to
to tail
not
off.
talk over.
You're trying, Das.
I'm
We
trying.
appreciate it.
I'm really trying. It's just
We are
there's-
coming up. Watch that
Roughly
perigee. It'll
15
take
seconds to
right
burn
up
out.
to about 140 to 200-ish in that range, and it'll shut down.
You have to understand, it's really hard for us to contain our excitement whenever we want to explain what's going. Oh, this is so cool! It does this and it does that, and then people
And there
talking
you have
over
it.
us. Jeez.
So a perigee
Ooh, man,
of 180.
I should have put money on that because I said 180 to 190.
You did.
Nice.
And you also notice it actually kicked that apogee all the way up to about 350, which is still
Cygnus
just
been
below
exposed
the
after
ISS
that,
altitude, so it's a
fairing
slightly elliptical
separation and
orbit,
will
but
continue to carry
that
the
looks like a
second stage
nominal
with
orbit
it
to me.
until about 9 minutes into the flight.
Nominal. Attitude nominal.
But it's all
Alright, so
nominal
we'll-
call outs.
All nominal, and like they just mentioned, they're going to wait to separate the actual spacecraft until about 9 minutes into flight, so about a minute and a half before spacecraft separation. And you can see some
Because-
thrusters firing to get into the right attitude for that.
Attitude nominal.
And the
expected,
prolonged coast
attitude
prior
control system
to
thruster
spacecraft
firings,
separation has to do with the
received.
fact that when you shut down when
Continuing
a
on
solid
course.
propellant vehicle shuts down, it doesn't immediately go to no thrust, right? There's still some residual burning going on in there, so they wait an extra 2 minutes just to make sure that there's no extra thrust coming
Roughly
out of that
1
vehicle.
minute to payload separation.
All the propellant has been burned. And
Altitude,
when you
185
use the springs
kilometers.
to pop off the top of the second stage, the second
Velocity,
stage isn't still going to have
7.5
thrust to come
kilometers
back
per
and
second.
slam into you.
No, we'll be quiet for a
All
second,
systems
and they'll be
continue
quiet.
to operate as expected.
Aha! I knew I could get them to talk. I'm in control of their
every approximately
Sorry, Dos,
30
go ahead.
seconds to spacecraft separation.
Sorry, Northrop Grumman, go ahead.
Well, I was going to say, when it pulses its thrusters, look over at the apogee, because the apogee changes a little bit every time you pulse a thruster.
Form as expected. Attitude corrections, maintaining expectations.
Because every time you pulse one of those thrusters, even if it's just to pitch it up or down, it's technically a slight velocity change.
And there we have it, spacecraft separation confirmed. And you can see actually that second stage fires those attitude control motors to point it away. So again, that's another residual thrust sort of mitigation, right?
That concludes our callouts.
Exactly.
Okay,
and if you can put the second stage into a tumble, it can create more atmospheric drag, because one of the reasons for leaving perigee at 180 kilometers is so that it's still low enough so that atmospheric drag will bring it back down naturally within 2 weeks.
So there we go. So that wraps up what has been a very successful launch of the Cygnus NG-15 spacecraft, the SS Katherine Johnson, which will arrive at the International Space Station in 2 days on Monday. Correct, Chris?
Yes, indeed. Monday. It's an early arrival. I believe NASA's coverage starts at something like 2 or 3 o'clock in the morning, with grapple and berthing 5-ish, 6-ish a.m. Eastern time on Monday. So very early, and that is actually mostly timed to the ideal time to get a spacecraft to the space station for the crew's workday, because the crew does not operate on Eastern Standard Time. The crew operates on Universal Coordinated Time. So 5, 6 o'clock in the morning in the East Coast is 10, 11 o'clock in the morning to the crew. So it's a ideal time to get a vehicle there for crew, because you don't have to sleep shift the crew to a different schedule that they're not used to.
So I don't think we're going to get them here. Are they going to stay live until we get things like solar panel deployment and other because they said they're ending the call-outs, but...
Yes, so that is a great question. So Cygnus, unlike most other spacecraft, does not have to pop its solar arrays right away. Cygnus has huge batteries, because it has to be able to accommodate a 24-hour, basically a 24-hour power outage, and still be able to operate. So its batteries are really big. So the solar arrays will not actually deploy until about 90 minutes into the flight. So we can expect tweets from Northrop Grumman confirming solar array deployment at that point.
Yeah. Okay. Good deal. Because that's always one of the super important things. It's like, make sure the spacecraft solar arrays deploy, and it goes power positive so it can continue its mission. And a lot of times we're like waiting with bated breath for that. Cygnus can cruise for quite some time there, like you said, with the batteries on board before it has to worry about deploying those. And Cygnus, doesn't Cygnus now have the sunflower solar panels? Are they circular now? Okay. At some point they upgraded to these different types of solar panels that sort of are this round shape, I guess. They sort of fan out like flowers, right?
Yeah, so and this had to do with Cygnus's evolution, because it was originally a smaller vehicle.
Right.
And then they went from the standard Cygnus, and then they went from standard Cygnus to enhanced, which was bigger, could take more cargo, so they needed larger solar arrays and more efficient solar arrays, but also, crucially, lighter weight solar arrays, so that they could help counter increase in vehicle mass by making it bigger, but they could decrease part of that by making the solar arrays a little bit lighter weight material.
Gotcha. Look at this. I just noticed the photos they have on the wall in the background make it look like this is in space. See how they put the different photos together? I looked at that. I was like, wait a second, what is that? But I want to cover something really quickly here, y'all. This is important to me. I see a ton of people in chat, and they're like, "Oh, it's such a boring rocket launch. Oh, geez, this is boring. Oh, no cameras on rockets." You know something? Boring launches sometimes are exactly what you want. The mission here is not to entertain you so that you'll click like on the YouTube channel. The mission is to take supplies up to the International Space Station. Science and new experiments and replacement equipment, that's what the purpose of the mission is. So people in chat, they're like, "Oh my gosh, it's so boring." Oh, well, guess what? If it was a super exciting launch, it might be that the supplies are not making it to the space station. So sometimes a boring rocket launch is exactly what you want. This is basic blocking and tackling. This is important to the operation of the International Space Station. So we don't really want a lot of excitement here, right?
Exactly.
It's like it's getting me because people are over here like, oh yeah, geez, SpaceX barely has to say anything during their mission control is so quiet, you know, and they don't call that boring that SpaceX isn't making a lot of commentary on their launch net, but then they're like, oh, there's no cameras on the rocket, it's so boring. Like, geez, come on. The important thing here is we're getting more supplies up to the International Space Station. We have lots of different rockets that can do that. We're not relying on one rocket or one engine or one spacecraft or one launch pad. That's the entire purpose of the way they put these programs together. We can launch on Antares, we can launch on Atlases, we can launch on SpaceX, we can launch from Russia, we can launch from Japan, all the different ways that we can support this because we never want to have all of our eggs in one basket, right, y'all?
Indeed, and in fact, to that, Northrop, what is now Northrop, what was Orbital Sciences, and the whole evolution of where Cygnus and Antares began, and who they've been bought by. But Northrop actually takes it a step farther than that, and Cygnus is actually launch vehicle agnostic as well. So if Antares were to have an issue, they could just pick up and go to an Atlas, go to a Vulcan. Heck, they could even go to a Falcon 9 if they really, really wanted to or needed to for various things. But yeah, Cygnus is also the only resupply vehicle for the International Space Station, only vehicle for the International Space Station that has launched on more than one carrier rocket from more than one location.
Because they've launched it on an Atlas before, right?
Yep, a couple times.
Twice, yeah.
Yeah.
Yes.
And that was a result of, like Chris mentioned, Antares had a failure once, and so while they worked on fixing the rocket, the spacecraft itself was fine, so they bought 2 Atlas V launches and launched it that way. Interestingly, the Dream Chaser cargo spacecraft that's coming up will also be launch vehicle agnostic, so we'll have that same feature.
Indeed, and another weird thing, right? Because normally you design when you design a vehicle like Cygnus, right? You design it for a specific vehicle, right? So like you would design it so okay, the amount that it can carry is the amount the Antares 230 plus can launch, right? Except that's not what Cygnus is either. Cygnus can also be packed with way more mass than the Antares could actually lift to orbit. And part of that whole design for the CRS-2 round of contracts, which we're in right now, is NASA could come to Northrop Grumman and say, hey, this mission over here, instead of carrying 3,000 kilograms of supplies, we want you to carry 5,000 kilograms of supplies. And Northrop Grumman would go, okay, the Antares can't do that, so we'll go ask you for one of their rockets, because one of their rockets could haul that mass into orbit. And that's what they would do if they ever got into that need.
Good deal. Let me see if we missed anything else here. Let's see. Apparently, no one here, or Noon, says, hey, it's Rocket Jesus. Nice surprise and hello, disciples. I think they're talking about you, Chris.
I think you are too.
Noon, thanks for the support. Technical Fool with 5 pounds saying SpaceX had an exciting, with some air quotes around it, booster landing the other day. Still waiting to see what happened there. We are still waiting for more information on what happened with that Falcon 9 that took a swim prematurely.
But of course, I Still Love You drone ship did successfully bring the 3 seagulls back. So
that's true. We got to keep the important stuff, guys.
This morning on Fleet Cam, there were 3 seagulls sitting on the deck of the drone ship. Oh, they're like animatronic or something.
Back. Yeah.
So there's some
there we go. There's the capture coverage. Yes.
Yeah. So that is coming up Monday, February 22nd. That, of course, is going to be on NASA TV. Normally, we capture coverages and stuff, unless it's like a big crew mission or something going up. We don't typically live stream those because there's a lot of us talking over mission control when that happens. But that is coming up 2 a.m. CST, 3 a.m. EST. They don't have UTC up there, but what is it? Plus
that would
5?
Be 8 a.m. UTC.
Yeah, 8 a.m. UTC on Monday. And again, talking about capture versus installation, the difference between grabbing it with the Canadarm and then plugging it into the rest of the space, or the ISS. All right. And let's see here. Let's hop back over this way because we're about to lose that that clean feed from Wallops.
Yeah, clean in air quotes.
Yeah, there's one more here. Let me get this last super chat to make sure we don't miss it. It makes me smile that Thomas's family gives shout outs. All of you are amazing. I'm thankful you bring this to regular people. I'm a nana raising my special needs grandson, and we listen together and learn so much. Thank you. Quark Quinn, Thank you so much for the kind
Thank you
words,
so
sharing that
much.
with us. That's what we try to do. I know a lot of people come in and they're like, oh, these guys never stop talking, or geez, they're not professional. They need to sit there with suits and ties on to explain what's happening on the launch. Like,
And to be fair, we don't stop talking, so
We don't
fair
stop
point.
talking.
Well made.
It is true. We do talk a lot. We know there's different types of coverage for different types of people. People learn different ways. People enjoy different things. And our coverage is excited live commentary mixed in with lots of really good facts and explanations and sometimes wacky drawings on the screen.
And screaming sometimes, too.
And screaming sometimes and ripping your headset off and running around the room when we land a rover on Mars.
And then
that's
being
sort
made
of
fun of for wearing shorts in February.
made fun of. It makes sense that you should have shorts on.
No, I know.
In Florida, geez. But that is what we do around here. We know that it's not everybody's preferred type of coverage, but we know we get so many good feedback, so much good feedback, so many nice comments from people like Quark Quinn there. We're so glad you're able to watch the webcast with your family. You enjoy the explanations. Hopefully we're able to get you a little bit more excited, a little bit better understanding of what's going on. So thank you so much for the support, and thank you all so much for showing up. Hope you all are doing well out there. There's a question here that I want to get because the question is relevant to my interest and rest of my day. Ross asked, are you hosting NSF Live later, in addition to the Antares launch today? And we are. We actually have a special guest on NSF Live. We will be going live around 3 o'clock Eastern Standard Time. It's 3 o'clock, right? I need a calendar on the wall or something.
Yes,
yeah,
3 o'clock p.m. Eastern time. It's the same time every week, does.
Yes,
just to be
it
clear.
is. But it changes every week because I can't ever remember it, and it's always changes at the same time. At 3 o'clock, in just about 2 hours, we will be right back here live for NASA Spaceflight Live, our weekly show where we answer all sorts of questions. We cover all sorts of space news that happened over the course of the week. And this week, we've actually got a very special guest. Eric Berger will be joining us. How do we even introduce him? Of Ars Technica?
Yeah, he's the senior space editor at Ars Technica, and he's also the author of a very cool new book on SpaceX. So I won't be on the show. It will be Das, Chris Bergen, and special guest Eric Berger talking about this week in space news, which of course SpaceX will be a prevalent part of. So SpaceX, as well as the Mars landing, there'll be lots to talk about. So should be a good episode.
Absolutely. So that is coming up here, y'all, about 2 hours. We will be back for NSF Live. We know sometimes when there's a launch, we're like, okay, today's this launch or Starship test or whatever, so we're canceling. But today we are not canceling NSF Live. We'll be right back here for another hour and a half of live commentary, Q&A, and all the stuff that we like to do here on the channel. So last one real quick, Tennessee Ferry with a late-breaking super chat. Is there a way to find trajectory of launches, especially from Wallops, and the possibility of seeing it fly over from areas like coastal Long Island? Wallops, Tennessee Ferry, is actually one of the best things that you can do there. I don't know that I'm going to be able to get that tweet this quickly.
I can find it. I know.
There's a
what you're
graphic that
for.
they put out to show when you can see these launches.
Oh, I guess I should go to twitter.com, not tweet.com, like I just tried.
Tweet.com. I'm going to see if I can bring this up, but there's a specific Twitter account for Antares. Wallops does this pretty religiously, and we'll see if we can get you that so you can make sure you follow along and can see. If y'all toss it into control room, I can grab it real
I'm looking
quick.
for it, yeah.
I think it comes from the official NASA_Wallops account, but now they've tweeted 18,000 things about launch, so I'm having trouble finding it.
Including something with like a bunch of elephants on it, which I don't understand.
Yeah.
But
scroll. So, well, that maybe it's on the launch blog. I'm not sure. Anyways, we want to find this because it is a really cool thing that they spend a little bit of extra time doing.
Visibility. Got it.
Do you have it?
Got it.
Yeah, just toss it into chat for me real quick. Control center.
Yeah.
Thank you, Chris.
Yes.
There you go.
Again, y'all, we're like, oh, we're doing the outro, but let's get this one last thing because this is really a cool thing that they do. This is going to be a little dirty while I bring it up, but let's go here. Let's go back to here. That's not going to be anything, so we need to get rid of that source. Aha! Whew, got it. That's my browser right there. And you can see this is from the @NASA_Wallops account. And specifically for Wallops, they almost always do these information on how to launch. They actually give you a map, and it says at T+30, at T+60, at T+90, where you'd be able to see the rocket launch from. So they have the trajectory in there as bring this up in a new full screen so you can just see that. There we go. That's a little cleaner. You have the trajectory in there so you can see where the launch is going. You have different areas. So if you were over here at Virginia Beach, you could look in a specific direction at T+60 and be able to see it. Of course, it depends on weather, and it depends on are there clouds in the way and stuff like that. But Antares is one of the rockets that gets this visibility prediction map. United Launch Alliance does this sometimes too. I've seen ULA put one out.
Yeah.
Never seen one for SpaceX. And those
They don't
sort of
do 'em.
covers.
Yeah.
They don't do them. That sort of covers that. But for sure, make sure you follow at NASA_Wallops, because just about every Antares launch, they do a thing like this, and they let you know here's where you should be able to see it and the times you should be looking. So, anyways, we'll grab. Hey, Chandra Perkins, thank you so much for the new membership, and Blessings says, "Wow, I'm 74 years old, retired medic. What a fireworks display!" Nice. So everybody across the board, thank y'all so much for showing up. Thank you for the support, asking all the good questions in chat. We can never get to all the questions, but we appreciate y'all showing up and chatting. Thank you for bearing with us as we go through our commentary, trying to talk about what's going on and being really excited about it, while Mission Control is not giving us the clean feed that we were exactly expecting to get. But across the board, we do appreciate y'all showing up for these sorts of events that we like to cover. Again, we're the NASA Spaceflight team today on the broadcast. On this side, Chris Gebhardt, Assistant Managing Editor for NASA Spaceflight. Chris, thank you so much.
Hello. Thanks for joining us, and definitely check out NSF Live later today with Eric Berger.
All righty. You can follow Chris on Twitter. He's ChrisG_NSF. I'm doing my very best weather person impression, pointing up at the screen. And in this corner, Thomas Burghardt, thank you so much for joining us today.
Thank you, as always. Always a pleasure. And yeah, I'm just going to reiterate, check out NSF Live later. It should be a really good episode. And then we'll see each other on future live streams as well, coming up on some Starlink launches maybe next week. And I don't know, I guess there's that Starship thing in Texas. Something will happen soon. So stuff will be going on. If you haven't subscribed, do so, and you'll see the coolest stuff.
Absolutely. Y'all, Thomas we need to edit that at some point. It says editor, but he's live stream host, editor, camera operator, so many different things. Thomas, we appreciate you, what you're doing. And lastly here, I'm John Galloway for NASA Spaceflight. If you're not busy later, check out NASA Spaceflight Live, because we'll be going live again in about 2 hours. We are going to go ahead and end our live coverage of the Antares NG-15, CRS-15, whichever one we're calling that today, launch we just saw from Wallops. Look for us later today. We've mentioned it, NASA Spaceflight Live. But for now, we will see you nerds later. Thanks for joining us.
Propulsion continues to be normal.
The chamber pressure looks good.
Following up. Roger, roll, Atlantic.
Water towers, fly!
Flight outside of speed off. Speed off.
Yikes. You bet. Concur. We don't need any more of these.